So here we have a beautiful couple of pieces of carborundum. This is natural moissanite. That's what moissanite is, carborundum, or commonly in the chemistry world, it's called silicon carbide. Si, silica, C, carbon. It is the solid solution middle member of a series between carbon diamonds and silicon dioxide. They form together in fault line diamond deposits. It's the kind of sort of sparkly. Now wait for it. Whoa, huh? Look at this. This is a really, really cool color. Wowie. Shazam. Alright, so this is just as hard as a diamond. It is 10 on the Mohs scale of hardness. I happen to have a ruby here. This is a star ruby I'm working on. And you can see the star starting to come out there. Pretty cool. And we are going to scratch the back. I did one scratch on it already. You can see it there. Pretty definite scratch. But I will show you. We will take this and go, whoa, whoa. That's probably enough. There it is. There's your scratch. It scratches sapphire. Sapphire is 9 on the hardness scale. It is aluminum oxide as opposed to silicon dioxide. And the stuff that the silica comes from in my diamond deposit is volcanic ash, which is plagioclase feldspars, basically. The light metals are removed during weathering. That would be calcium and sodium. And they leave the aluminum oxide and the silicon dioxide in 2 layers. It forms a 2-layer clay called kaolinite. And if you look in pictures of opal mines over in Australia, that's what you see. Those white heaps outside the opal mines is kaolinite clay. And that's actually what the opal forms from. And this is some original research. I can actually duplicate the process in my laboratory from natural ingredients, which has allowed me to go out and find this stuff without luck. I use science, and I can locate deposits of precious opal And, well, in doing so, I found this deposit near Safford, and I have carborundum like this, diamond, and silicon dioxide in the form of fire agate. It also has colors and sparkles, and it's pretty cool stuff. Definitely cool stuff. So this is 10 on the Mohs scale of hardness. Let's do another scratch just for fun, okay? Find a good solid place. They're not real solid. They're kind of, these guys are anyway, kind of flaky, and I don't want to really break it. So I'm gonna use this base part of the thing so I can put at least enough pressure to get it to, and I'm not like forcing it. Okay. Now, let's see if I can get a good corner here. Okay, some of that is worn off carborundum. So when I wipe it off, a lot of that's gonna go away. But you know what? It scratched the sapphire because it's harder than sapphire. That's how the Mohs scale of hardness was developed. It's about 200 years old. It is not new science. We understand it a little better. It's like aluminum oxide, that's what corundum is an oxide, and the aluminum shares the electrons with the oxygen to become stable. In silica, there's a double covalent bond, two covalent bonds. Covalent bonding is the strongest bonds we know of in chemistry, and because they share the electrons, and that joins them together in such a way. Silica is so stable, it resists chemical weathering, like from rain, and river water, that sort of thing. And it resists mechanical weathering. You can walk on it and it doesn't wear out. There are steps in Europe that are made from granite, and you can see they wear out, right? They wear out. People walk on them and they wear out. In the town of Idar Oberstein, which is where the Romans used to mine agate, one of the shops had an agate step that was said to be 1,500 years old. It was looking like brand new. It had no visible wear on it because of the hardness of silica. 7 on the Mohs scale of hardness, and that double covalent bond. It doesn't want to come apart. That's what causes it. It's not magic. It's not something that some guy in the sky created. It's a chemical, 2 elements, silica and oxygen, or aluminum and oxygen, and they bind together, and they are just about as hard as you can get. This is the hardest it will scratch anything else on earth. Anything. Except a diamond. It will not scratch a diamond. Unless, you know the little bit of force that I put there? I can put more force on this and scratch a diamond, certainly. That's not scratching, that's gouging. There's difference. Big difference. Scratching, the scratch test, we're not trying to damage the stone. We're trying to measure the difference in hardness of one stone and the other. And we know these things. They are written down, and we can look them up, and every geologist that ever took a geology class knows the same thing. It's science. It's not made up. I didn't make it up. I'm a scientist. I learned it in books. And then I went out and looked. I went and looked for 30 years. That's what I've been doing. I worked for Raytheon Engineers and Constructors, Fortune 500 company. And in the meantime, I went looking for rocks. It paid for my rock habit. And it also allowed me to finish my graduate research for my doctorate. So that's where I am. That's what I do.